let me give you another example, okay? Like it is still like, again, it is a little bit complicated, okay? But you can do it, okay? So like the most complicated part is like in table number 13. So that's why let me write your number 13 on the side, okay? Number 13. Again, everything is in the table, okay? And your f of t is u ct times f of t minus c is equal to inverse Laplace transform of e to the minus cs times f of s, okay? Well, like capital F of s is the Laplace transform of f of t, okay? That's it, okay? So now let me rewrite this, okay? Definitely your denominator is not concerned with this form, like any form on the table, right? So that's why we have to do the partial fraction, okay? So this will be written as, okay, what I'm going to say is e to the minus 2s and 1 over square s minus 2, okay? And then this part can be written by, okay, let me factor this out as well. It is equal to e to the minus 2s times 1 over s minus 1, s plus 2. That's okay. I'm talking about this, okay? It is equal to a over s minus 1 plus b over s plus 2. Then you can easily compare your left and right hand side. Then you can find a and b. Then let me give it to you, okay? It is equal to e to the minus 2s, and your a is 1/3, and plus negative 1/3 over s plus 2, okay? Then, which is equal to 1/3 e to the minus 2s times 1 over s minus 1, and minus 1/3 e to the minus 2s and 1 over s plus 2, okay? And we can apply number 13 to this guy and this guy separately, okay? Let me try to use different color for each of them, okay? Here we go. And look at the, like the chart of table number 13. Look at that. Like your function is e to the minus cs and times f of s, right? So let's say this part is f1s, okay? And let's say this one after, so we're going to take it separately, okay? Here we go. Then by the Laplace inverse Laplace transform, okay, it will be f of t, which is equal to inverse Laplace transform of f of s, right? Which is 1/3 inverse Laplace transform of e to the minus 2s times 1 over s minus 1, and minus 1/3 inverse Laplace transform of e to the minus 2s times 1 over s plus 2. Is that clear? Then let me use like a red color for this, okay? This is f1s again, okay? And this is f2s. What I want to do is like, I would like to find f1t and f2t, which is concerned with like this f1s and f2s, okay? So here we go. Where f1t is inverse Laplace transform of f1s. What is that? It is equal to, just check number 2, right? It is e to the 1t, right? And f2t is equal to inverse Laplace transform of 1 over s plus 2. That is e to the minus 2t. Just like same thing, check number 2, okay? And we almost here, okay? These are f1 and f2, right? and it is equal to 1/3 unit step function in f1 t minus 2 minus 1/3 ut and f2 t minus 2s. Okay, well, like I had to write like this red part below. Let me do it. This part must be going to below like that, and let me write everything here. This is better order to write. Okay, almost there. It's like we can plug in t minus 2 into f1 t, right? It is equal to 1/3 u to t times e to the t minus 2 minus 1/3 u to t times e to the minus 2 and t minus 2. That's it. My son is here.